Pardon me. Okay, we're going to talk about engineering, materials engineering, and introductory presentation. This is put out by the American Ceramic Society. Lists a lot of their work. We've added some videos and things to explain it. A lot of the great advances you see are made through materials engineering because it's these new materials that allow us to make new things. Yeah, that was the 3D Polar we were having problems with. Someone was asking about the Polar 3D. And here it is. You can see on the camera, it was measuring how high up and down it's going to go. That's the mirror. Believe it or not, that's glass, but it has a bunch of glue stick on it to help it stick. So it's bouncing up and down there. All right. Now, so, whoa, let's go here. We're going to go ahead. We'll be talking about material engineering tonight. We'll also check in on that 3D printer from time to time. And we'll have some pretty cool abilities on glass. If we get done early, if you haven't submitted a checker with your first name, with your location, and high school in it, please do. You can work on that. So here we go. And there's a great story I've often heard. Okay? And you don't often hear this, but the fact of the matter is, the Wright brothers, if you look back at the way they made an airplane, there's a lot of the reasons if you went back, knowing what we know about aeronautical engineering, you'd have to make a lot of the same compromises. You would make it out of wood. You would make it out of cloth. Why? That was the major material. Aluminum had been invented, but it hadn't been massively produced. It was still a bit of a strange bird. After World War I, it becomes, that's actually, airplanes are the killer app for aluminum. They start using it all the time to make airplanes. But so it's twice as strong. And so these new materials really make a big difference and allow us to do lots of things. One thing you're seeing on phones now is we don't want them to scratch on the metal side. And one that was announced, they thought Apple would be using, they've started using it for removing SD cards. You should see it in the body of some of their equipment down the road, is liquid metal. And it's twice as strong as titanium, very resistant to scratches, very resistant to marks. Here, by the way, the printer's now going to start laying on a print. There it is. So you can't hardly see it. We'll come back to it in a minute. All right, so now let's go to here. All right. I want you to see this.
I'm Mike Fowler, owner of 1 Hour Heating. I'm so confident that you'll be satisfied.
That was liquid metal, and it's a pretty cool material. You're seeing it going to be used more and more in phones. Now, another material you've heard a lot about probably is graphene. What's amazing about graphene is you can literally get it by using a little bit of tape and some lead pencil. It's been right in front of our nose the whole time. It's strongest material ever measured. It's 100 times stronger than steel. It's stiffest, it's the thinnest. However, it's the next big thing, but we got to be able to manufacture it. So let's go ahead. We're going to watch this little quick YouTube video. Before we do, let's take a look at our printer. We're starting to get this down here. We got a little bit of gunky stuff from the stuff, but that's the original laydown. I think we'll be okay. All right. Whoops. So I'm going to go ahead. You can watch it this way in case you're you can't. When I do it, there's too much of a lag. All right, now I'm going to put this up. And that's the big thing. It's of limited use right now because we haven't been able to manufacture it. And it's like anything they found in 2004. It's now 10 years, 11 years later, and we're still not being used in anything. It takes a while. It's one thing to discover or invent something, another thing altogether to manufacture it. A guy named by the name of Friedel made this kind of broad statement. The more innovative, the more breaking the mold the innovation is, the less likely we are to figure out what's really going to be useful for. So when we just make these discoveries, you're making things you may or may not know. Restricting adaptations in the marketplace, or why I don't see this wonderful stuff in stores, you have to be able to make it, so you got to be able to manufacture it, and it has to be a lot better or a lot cheaper than existing products. All right, so there's a threshold you really have to get through. Give you a couple examples. We developed silicon that you would use for silicon chip, and basically the chemistry, it was 100 years before discovering silicon, and we were able to make chips out of it as a semiconductor. Aluminum will even be more detailed. In 1850, we discover aluminum. We come up with a very painstaking process to get aluminum out of the dirt. It was amazing because they said, wow, you're finding silver in the dirt. Well, it's really not silver, but it looked like it. It's light, didn't rust. Pretty amazing. They used to put it in expensive jewelry. In the 1880s, a professor, and I believe he was out of Oberlin College up in Ohio, is actually the person I think who did this, figured out a way to mass produce it using electricity. It was used in kitchenware, it was used in things, but still not used everywhere. I mean, you could get a Sears and Roebuck's catalog and they have aluminum cooking stuff. What really drove aluminum to its heights was we started using aluminum in making airplanes. Now you're gobbling up lots of aluminum. All right? All right, so let's talk about material sciences now. And before we get too started on that, let's take a quick look at our print. All right, you can see it now. We got a little more circular here. We're still got a couple layers laid down here, not a lot. We'll come back to it a little bit. Well, let's get back over here. All right, we're investigating the relationship between the atomic and molecular structures of a material and its micro and macro properties. In other words, its little properties and its big properties. Examining and understanding what influence these properties of a material so the right material can be selected for a particular application. Typically, they fall into four categories: ceramics, metals, polymers, composites. So what's a ceramic? Inorganic, non-metallic, solid created through heating and then cooling. Some of the properties of ceramics, they're generally brittle. If you've got Corningware in your house, many of us do, you'll see that. It's hard, but it's strong in compression. Not so good in other types of loading, like tension where you pull things. But it's really good against corrosive materials, and it can handle high temperatures. And some of the common ceramic materials are silica, which we think of in sand, aluminum, Corningware, porcelain are all forms of ceramics. Glass is not. The internal chemical structure is different. This is more the molecular layout of this is much more rigid, is much more spaced out. Where in glass it's amorphous, where it kind of oozes back and forth. This is more crystalline, more, I'm trying to think of the right term here, and of course I'm going to forget it, but it'll come to me in a little bit. What is a metal? An element or compound that has good electrical and thermal conductivity. They're usually, like I say, they're real good about conducting electricity. They're malleable, they're ductile. What that means is you can mold them into shape. They can be bent. That Corning ceramic ware can't be bent. Some examples: iron, copper, gold, silver, tin, alloys, combination of things, steel, nitinol. All right. Now polymers many reading subunits. So think of a lot of plastics are polymers. You keep repeating these same elements. They tend to form glasses and semi-crystalline structures rather than crystalline. And crystalline is what I was looking for before on the ceramics. Polymers are strong, flexible, non-reactive, and moldable. We just said that. PVC pipe, guys, we were using that to make our weapons. Wool, it's always strange to me wool is considered a polymer, but I guess it is. Shellac, rubber, nylons. A composite is when we take the best of both materials, put them together. And a lot of times, that's just what we'll do, is we'll take the best of both worlds and put them together. So that's what a composite, if it's made up of the other four things together. So like, here's cement, water, fine sand, coarse gravel, you get concrete. Concrete, most widely man-made material, composed of Portland cement, water, and aggregate. Wood, it's a natural one, composed of cellulose fibers, the cells that are with natural glue called lignin. I'm saying it wrong. Tires, rubber, or one or more types of fiber. They have to be able to hold air inside while being able to withstand the stress of being driven on. All right? So, now glass can be heated in some real-world applications, and glass is somewhat of a composite. You can add different materials to make colored glass. And you can do different heating techniques. Now, what I'm going to show you next in terms of glass, it's a great way to see what a little bit of the history of technology goes, and then what's called Willow Glass, and that's coming out now. That's bendable, pliable glass. We figured out ways to manufacture it. You're going to start seeing it. This was honestly an infomercial by Corning, who makes glass, but it's from the guys in, there we go, let me copy this, please. Mythbusters. And so it's pretty good. It's a little bit longer than the ones we watched, but we're going to go ahead and do that one now. Again, don't want to make a big deal out of necessarily just Corning, but I do think those series of videos give you an idea that with new material engineering and material sciences, it gives engineers new palette to work from, and you can come up with all kinds of exciting things. I'm real interested. I found this plastic that's coated with a material that is totally clear and absolutely conductive. It's not water, you know, but I want to work with it. Now, how do you use it? You literally scratch your insulation, you scratch some of the material off so it's separated from each other. So that way you can have a hot and a ground, for example. So with that in mind, if you've not already, give me that checker, 45 by 45 up to 10. Make sure you put your location, your first name, not your full name, and high school, middle school, 5th and 6th grade. Make it public. Share it on the link on Edmodo to me. Make sure we get that done. Now you can spend the last few minutes here working on Code Combat. And we did a poll a little bit here, and you know, it showed that you guys enjoyed this. I was glad that you liked the class and the material. I think it's pretty fascinating. Wednesday I won't be here, but Tom DeToy will be taking over for me. All right? Okay. Thanks. Bye.